Okay, so hello everyone. I'm Molly, and my research topic is autism and age predicts spatial perspective taking ability in children. So, first of all, let me introduce what spatial perspective taking is. We can first understand the definition of social perspective taking. Look at the picture on the right side, and we can see two people talking about something, and the third person on the far right interprets the emotion of the people in conversation based on the content of the conversation and their facial expressions. So this person is using his social perspective taking ability, which is to decipher the thoughts and feelings of others. So now we can have a closer look to the concept of spatial perspective taking. Similarly, it consists in seeing a space from a different perspective, adopting new imaginary orientations, mentally viewing a scene from an external viewpoint. For example, in this picture, the two people have different interpretations towards the number because of their different spatial position. So after we understand the meaning of spatial perspective taking, let's look at the background of my research. In my research, I look at spatial perspective taking ability from two perspectives. The first one is whether the participants have autism spectrum disorder or not. According to the official definition of autism, it is a condition related to brain development that impacts how a person perceives and socializes with others, causing problems in social interaction and communication, which means that people with autism have deficits in social skills. At the same time, there is variability between autistic people and healthy people in general intelligence. Therefore, we can reasonably speculate that there are potential deficits in spatial relational processing for autistic people. That comes to one of my research questions, which is how is spatial perspective taking ability in children with autism spectrum disorder compared to the healthy controls? And the second perspective is the age. I want to investigate how spatial perspective taking ability changes in children with autism as they age. There are mainly three possibilities that can answer this question. The first possibility is that the autistic children do have deficits in spatial perspective taking ability. Their spatial ability is worse than normal kids, and also they have a slower rate of development in the ability. And the possibility too is that spatial perspective taking ability is protracted rather than a deficit. That is, the autistic children possess a delay in the development of the ability. Their spatial ability is still constantly worse than the normal kids, but they do develop at a similar rate. And the third possibility is that the autistic children have a much worse spatial perspective taking ability than normal kids do initially, but they have a faster rate of development in the ability. When they are at a very little age, their ability is very weak, but as they grow older, they gradually narrow the gap between them and the normal people, and gradually catch up with the ability level of normal people. So these are the three possible explanations. And now let's move on to my overall research question and my hypothesis. So my research question is, how does spatial perspective taking ability change with autism and age? And for my research, the participants are 6 to 9-year-olds with autism and healthy kids of the same age. I have collected 40 effective samples in total, and there are 4 groups that those are 6-year-olds with autism, 9-year-olds with autism, 6 years old healthy kids, and 9 years old healthy kids. So I have 10 samples for each group. And my hypothesis is that compared to healthy children, autistic children had lower accuracy on the test of spatial ability and were more developmentally delayed between the ages of 6 and 9. So here is the method I have used during the research. I designed a test with 10 questions regarding spatial perspective taking ability and assigned the test to each individual participant. The test contains two types of questions. One is the multiple choice questions, and the left picture is an example. I will provide the test takers with a scenario, and that is, imagine there is a photographer who goes to the museum and he wants to photograph these solid geometries, and his direction of the view follows the arrow in the figure. The participants should find out the correct picture that he will take based on his angle of view. So for this question on my PowerPoint, the answer should be number 6 because that is what the photographer can see from his position. And the second type of questions is matching. The children with autism need to know which image each person in the picture sees of the same object and match them together. For this example, the girl with orange dress could see the whole image of the cat, which for her covers the vase. So she should be matched with this one. And for the boy who wears the blue clothes, he could see a cat on the left and a vase on the right. So this one is the correct answer. So the participants are tested on the quiz with the combination of these two types of questions. And here is the result. I graphed two data sets, which are response accuracy and the response time. Let's look at the graph of response accuracy first. The blue line in the graph represents the result of healthy kids, and the orange line represents the result of autistic children. From the graph, we can see that there is no interaction between the factors of autism and age. The interaction effect occurs when the effect of one variable depends on the value of another variable. And it has a p-value of 0.56. For the factor of autism, healthy controls constantly have higher response accuracy than autistic children, with a p-value smaller than 0.001. And for the variable age, similarly, 9-year-olds have higher response accuracy than 6-year-olds, despite whether the participant has autism or not. It also has a p-value less than 0.001, indicating that my result is statistically significant. And then we can move on to the right graph, which shows the response time corresponding to different ages and autism. This graph shows that there is still no interaction with a p-value of 0.893. In addition, healthy controls always spend less response time on completing the test than autistic children do, and 9-year-olds take less response time than 6-year-olds do. For both variables, the p-value is less than 0.001. Thus, we can make some conclusions and discussion. First, the conclusion of my research is that spatial perspective taking ability is weaker in autistic children than in healthy controls, and the ability in both healthy and autistic groups gets stronger with age, which confirms my hypothesis. Then for the further discussion, it's worth noting that based on my results, spatial perspective taking ability might be protracted, but not a deficit. This is because the graphs on the previous page show that the children with autism spectrum disorder have certain spatial perspective taking ability. They can reach the normal level, but it just takes more time. They have a delay in the development of spatial ability. It is not that they can never possess that ability. So we can have some possible interventions to improve their development of spatial perspective taking ability. We can focus more on the exercise or practice of perspective taking for autistic children. For example, add games and questions to daily teaching to improve relevant skills and to encourage them to stimulate and use their spatial thinking. And lastly, I want to introduce the significance of my research. First, the related research fields for my study are educational psychology, cognitive psychology, and developmental psychology. My research suggests potential directions for special education, such as cognitive training in specific domains like spatial reasoning, and helps lift special education efficiency so that we can help the people with autism spectrum disorder to have a better life. And at the same time, my study contributes to the broader field of cognitive development of children with ASD. And we consider it a starting point for more systematic investigation of the development of spatial thinking skills in children with ASD. So that's all for my presentation. Thank you for listening.
Wow, that's a really great work.